Good day and welcome to this episode of Engineering Maths. We're having vectors. It's the continuation part of the one we started in the previous video. And now we're going to be dealing with the component of vectors. Just two examples on that. This might be broad, or if you can follow up to the end, it's going to be very helpful. So now, component of vectors, we have the first question. We have points LMN are midpoints of the sides AB, BC, and CA of a triangle ABC. So this is telling us that we are dealing with a triangle. So firstly, we draw our triangle out. We have our triangle as such, and we are told that it's ABC. So we labeled it. We have A, B, and C. Now let's take the midpoints. L for BA and for AB rather, vector AB. So this vector AB, that means that N, the midpoint is here. I put my L here. For BC, the midpoint is what? M. So this BC, the midpoint is what? M. And for CA, the midpoint is N. Now, adding the direction, since it's AB to BC to CA, we have something like this. AB to BC to CA. So this is the triangle given in the question. AB, BC, then CA. And now we've indicated the midpoints LM and A. So now what do you have to do? Connect this midpoint to the corresponding corner rather. You have something like this. You have this coming here. You have this also here. Now the usefulness of this is that when we are defining each vector, you will know where that vector leads to, the component of that vector. So now for this, we have AB plus BC plus CA. This is a normative. You know that this is a closed loop vector. And when you are having a distance from AB plus C plus BC and plus CA, that will give you 0. So but we can also solve for that using the addition of vectors. So we can say AB plus BC plus CA. If you take this one, you see that this will cancel out and we have AC, right? So this is AC plus CA. Now back then in the first video, you notice that if you can represent this CA in another way, and you can say that CA is also the same thing as minus AC. Why? Because you are making it flow in the direction of what it is opposite of before. So now you are saying this CA now is going here. This CA is going here, so we are turning the direction upside down, and surely the sign will change. So that's why we have minus AC here. We explained that in the last video. So now we have AC minus AC, which will be 0. So we prove this now. We are done with A. Now second one, B. It has to do 2AB plus 3BC plus CA equals 2LC. Now, as usual, we define each vector. And what are the vectors? We have AB, we have vector BC, we have vector CA. So to define each vectors, let's start with AB. Now to define AB, notice AB very well. Any vector you are going to define here, make sure that the midpoint is involved, most especially this LC, because it is what we want to prove. So now, this vector AB now, I can say vector AB, it is 2 of vector AL, because the length of AL here is another length of AL here, which will give me my AB. So what am I saying? I'm saying that vector AB is twice the vector AL. And as such, we are having 2AB in the question. Let's insert that 2AB. So if our AB is this, what will be our 2AB? Our 2A will be what? 2 into bracket 2LA, and that's what? 4AL. 4AL rather. So we've gotten this. Now let's move to the next one. That's BC. Now BC. How do we get our BC? Involving the midpoints. Now you can see this is BC here, but it also has a component that can flow through from here to here. So we can say BC, vector BC is equal to vector BL plus vector LC. See, we are already having our LC already. We are getting there. So now say BC is equal to BL plus LC. Now, but in the question we are having what 3BC. So let's insert what we have in the question. So if BC is this, what will be 3BC? 3BC will be 3BL plus 3LC. Right? So we've gotten our 3BC also. Now, for CA, now how do we get that? We have CA. CL will be what? CL plus LA. It's also the same method. So CA will be what? CL. That's we are involving the midpoint plus LA. Okay, now the CA we have, so we don't need to change anything there. We have our AB. We have our 2AB, which is what we have. This is what we make use of. Then we have our 3BC also, which is this. Then we also have our CA. Now we can add up. So what do we? Let's add up according to what we are given. So we say 2AB plus 3BC plus CA equals to our 2AB is what? 4AL, then plus our 3BC is 3BL plus 3LC. 3BL plus 3LC. Then our CA is CL plus LA. CL plus LA. Now we have some common factors here, but we have to still change some. Let's look at some related terms here. We have AL here. This is AL coming. Then we have BL. Now this BL, now I can change it to AL. How? I can change the direction upwards and it will turn to what? Minus AL, just like we did in the last video. So this BL can change to minus AL. So such I'll be having if BL change to minus AL, so this one will turn to minus 3AL. So let's look at another one again. We have LC. This CL also, CL can change to what? Minus LC also. Yes, you can turn the direction back. If it's coming here before, we can turn it back and turn it to minus LC. So we have CL is equals to minus LC. Now let's insert it there back. We having this is equals to what? 4AL. That one remains unchanged. Then our BL now will be what? Minus AL. So we are having minus 3AL here. Minus 3AL. Then plus 3LC. Here will be minus LC because CL now is not our LC. So minus LC plus LA. Okay, yes, we can change LA to. So you can change LA to minus AL, right? Yes, you can change LA to minus AL. So LA is equals to minus AL. So here now we have minus AL. Now you can see that we have related vectors here. Now we have 3 ALs here and we have LC. So it's very simple to simplify now. So 4AL minus 3AL minus AL again. So minus 3AL minus AL, that will give us minus 4AL. So 4AL minus 4AL, that one is gone already. That means all these are gone basically. So now it means 3LC minus LC, and that will give us what? 2LC, which is what we asked to prove in the question. So we've gotten our final answer, 2LC. So finally I can just say 2AB plus 3BC plus CA is equals to 2LC. That's proved already. So we are done with this also. Now the last next indication is question C. We have to prove that AM plus BN plus CL is equals to 0. Let's write that out here. C is equals to plus BN plus CL is equals to 0. So we define each vector as usual. So defining am, this is am here. So I can say am is ab plus bm. Also I can also say it's ac plus cm. But let's use ab plus bm. So let's go. You see am is what? ab plus bn as the first one. Now for bn, this is bn, right? You can say bn is bc plus cn. You can also say it's ba plus an. But let's use bc plus cn. The reason why we are choosing it, I will make it clear when we are done. So say ba is equals to bc plus cn. And for the last one, cl. So we have cl, yes. You can either say is ca plus al, or we say cb plus bl. I choose ca plus al. So cl is equals to ca plus al. Your diagrams are very important. You can see I'm going back to it to go and reference. So it's very, very important to have a diagram in check. So that's it. So now that we've gotten all our vectors defined, you know this is our am, this is our bn, and this is our cl. Now the reason why we were selecting one side of the vector components over the other is that you notice that now if you are going to combine this together, you can have ab plus bc plus ca. That's a closed loop. Then the second part can also be simplified. But as you just choose any other angle, maybe just choose the angle, you notice that you might not be able to sum up the related ones, or it might be more complex. So that's why we choose one side over the other. So now we are having, let's sum up everything according to what we are having. We'll be having ab plus bn plus bc plus cn plus ca plus al. As you can see, and I said we have ab plus bc plus ca, they are related. We pack them one place. Then we have bm plus cn plus al, they are related also. We pack them. So we are having ab plus bc plus ca, then plus bn plus cn and plus al. But then you have to manage our space here. So here now. So here, you notice that AB plus BC plus CA is a closed loop, so it will lead to 0 because when this cancels, we have AC here, and AC plus CA, you see, CA will turn to minus AC, which will lead to 0. So this one is gone already. So for this, we are going to simplify this further, and simplifying that, we have BN. If you check your BM, you see that it is half of BC, right? So BM is half of BC. Let's do that. BM is equals to the half of BC.
I'm doing so. Next one.
Also, if you check CN, you see that CN is the half of CA. We are following that direction. Don't can say CN is the half of AC. No, CN is the half of CA. So CN is equals to the half of CA. Then the last one, which is AL. This AL, it is the half of AB. AL. AL is the half of AB. So now we can combine them together. We have BM plus CN plus AL is equals to half of BC plus CA plus AB, which is also a closed loop, because if you notice well, see that this goes out with this, and we have BA then plus AB. You turn AB, you flip it, you have minus BA. So BA minus BA will be 0. So we also have half into bracket 0. Remember, this one is also what? 0. So we have our equation am plus bn plus cl is equals to this, which amount to 0, then plus half into bracket 0, which is also equals 0. So that is the proved answer for this question here. So we are done with this. We are done with this here. So now we have a quadrilateral ABCD in which PQ are the midpoints of the diagonal AC and BD. Now let's not get it twisted. Let's just know that we have a quadrilateral in check. Now this quadrilateral now has two diagonals, and the diagonals are represented like in an X form because the diagonal divides two equal parts. So we have AC and BD. So first thing to do is to draw your quadrilateral and this way. So let's label ABCD according to how we have it. Now ABCD. Now diagonals AC and BD. So let's indicate that also. Diagonals AC. So A going to C direction and B going to D. So that's it. So what else? We have the midpoints P and Q. So let's say this is the midpoint, and we have P and Q here. P and Q. So it is said to be, have represented that equation in a diagram. So the only thing that is made now, we just have to put our directions so that we don't get confused when we are defining the vectors. So now AB, we put this arrow here, then AD, we put this arrow here, then CB here, then CD here. Now defining each vectors. Now let's pick AB and let's define it. How do we define AB? Take note, we are proving that if this is equals to 4PQ, so whatever you are going to define, make sure that it includes what? PQ, not QP, PQ, because it's going to help you when you want to sum of everything. Now AB will be what? This is AB. So you can move from here to P, from P to Q, and from Q back to what? B. So we'll be having vector AB will be what? Vector AP plus vector PQ plus vector QB. So now let's see vector AP plus PQ plus QB. So that's it. This is what we did here. We have something like this coming here, then this here, and this back here. That's what we did. That's what we brought out here. So we are having this vector A, and we have B. So it's going this way, right? So here is our P, here is our Q. So it went like this, then came back to B. That's what we did. Yes. So the next one, dividing AD. What do we have there? Here's our AD. This is AD. So it's even more simpler because you just have to go here, and come down here. That's all. So we have vector AD will be equals to vector AP plus vector PQ. You can see that PQ is still reoccurring. Then vector QD. Correct. So that one is just like a quadrilateral too. You have something like this here, and this is AD. This is direction. Then we have our PQ. So it's going this way here and coming down here. So that's for that. Then the next one is CB. How do we define our vector CB? Now let's check. It's CB, and we want to make sure that we have a PQ in our definitions. So we make sure that these are we go from here, we come here. That's it. So we have vector CB is equals to CP plus PQ, because we are coming here, then plus QB. That's for the CB. And in that case, we are having something like this, and something like this here. Yes, I have not like that. So we have C, we have P, we have Q, and we have what? B. Right? So notice that this is we are going from here to here, right? So we passed through here, came down here, and we went back here. So that's for that. Then last one is CD. How do we go about CD? Let's check that out. This is our CD, right? So you can go through here, come here, and come down here. So we have CP plus CQ plus QD. So we are having CP plus PQ plus QD. And for that, you see that we have something like this here, then we have something like this. So this is PQ and this is DC. We're going from C to D. So we have the arrowhead here. So we passed through here, came here and landed there. So that's that for the vector definition. So we have the 4 vectors defined now. We notice that PQ is common, is common, and we also have some that are also common too. See, AP, CP, CP, then QB, QB, QD, QD. So when we are arranging the vectors together, we will know what to do. So now let's proceed. We have AB plus AD plus CB plus CD. Now let's combine everything together. Put it in brackets so you don't get confused. So AP rather plus PQ plus QB. That's for the first part. Then plus AP plus PQ plus QD. That's the second part. Then we have here CP plus PQ plus QB. Then the last part we have CP plus PQ, then plus QB. Yes, so now we can sum up the related ones. We can see that AP, we have 2 AP. So let's start bringing them together. 2 AP. What is related there again? CP and CP is related. So we have plus 2 CP. Then here we have QB and QB also. So plus 2 QB. And we also have QD. And is there another 2 QB? No. This is QD, not QB. So we have 2 QB and 2 QD. So 2 QB and 2 QD. So okay. And lastly, we have 1, 2, 3, 4. PQ is 4. So we have 4 PQ. See that we are getting closer to what they were asking us to do for. If you are getting 4 PQ now as just the vector out of all, that means all the rest will tend to 0. But how? We are going to check that. So we have 4 PQ here. Now let's come and face these guys here. Now we have AP, we have CP. Are they related in the diagram? Let's check. So this is AP, okay? This is SCP, this is CP. Wow, yes, they are related. How are they related is that you can turn CP in the opposite direction and you turn towards minus AP. We did that in the first episode. We said when we have a vector going in a direction, you turning that vector back will make it be minus. So now you can see AP is opposing CP according to what is here. So if you are turning this CP back, it's going to be minus AP. So let me just try to say that. Note that CP is equals to minus AP. That's the first one. Now let's check the second one. We have QB and QD. Okay, this is QB and this is QD. Okay, they are also going in opposite direction. You can see QB is going here, QD is going here. So what happens here? You can change QD. You can also change it to what? Minus QD, because since they are opposing each other, you can bring that direction back. and it will be the inverse and the negative of the one facing it before. So now we are having QD as minus QB. And so we have our answer already. Because when you look at it now, you can see 2AP minus CP now is already what? Minus AP. So you have minus 2AP here. Then plus 2QB. And now that QD is what? Minus QB. We will be having what? Minus 2QB here also. Minus 2QB. Then our boss here, which is 4PQ. So you can see that all this will what? Tend to 0, 0. Then we have only 4PQ left. So now you can see that our answer will what? We end at 4PQ. So you can just write the question which is AB plus AD plus CB plus CD equals what? 4PQ. So we can say that we have proved our answer. So this is the end of the video. Do well to like, share and subscribe. Thank you.